j omega will be equal to 2 times the Fourier transform of delta t is 1, as we have shown earlier. So x of j omega will be equal to 2 over j omega. So the Fourier transform of signum of t is twice over j omega. I hope that is clear. Okay, so in this problem we have to determine the Fourier transform x of t, where x of t is equal to u of t. So I hope you understand what u of t is. Unit step function, we have used it multiple times in the previous examples. So as we have seen earlier, we know that a signum function can be written as twice u of t minus 1, and from this expression, by the virtue of cross multiplication, we can write u of t to be equal to 1 plus signum of t divided by 2. This can also be written as 1/2 plus 1/2 of signum of t. Now taking the Fourier transform on both sides, taking the Fourier transform, we can write u of t will have a Fourier transform of capital U of j omega, and half can be written as half times 1. So half remains as it is, and as we have seen earlier, 1 will have a Fourier transform of 2 pi delta omega. And similarly in signum, in the second term, half remains as it is, and the Fourier transform of signum of t is twice over j omega, which can be written as, this 2 cancels out, this one also cancels out, pi delta omega plus 1 over j omega. So the required Fourier transform x of j omega, which is equal to u of j omega, and gives us the Fourier transform pair pi delta omega plus 1 over j omega. Hope this problem is clear. Now moving on to the next part of the next problem. We are to determine the Fourier transform of x of t, which is equal to e to the power minus a t times signum of t. Okay, let's jump in the solution. As we have seen earlier, e to the power negative a times the modulus of t will look like this: e to the power minus a t, and the signum of t will look like this. This is shown in the previous examples. Now then, moving on to the solution, we know that from the direct transform equation x of j omega is equal to negative infinity to infinity x of t e to the power negative j omega t dt. Now this can be written as negative infinity to infinity e to the power minus a t signal of t e to the power minus j omega t dt. Okay, then x of j omega will be equal to, now look carefully, as we have seen before, we can write e to the power minus a to be equal to e to the power at when t is less than 0, or minus at is greater than 0, and 1 at t equals to 0. Similarly, signum of t can be written as 1 for t greater than 0 and negative of 1 for t less than 0. So dividing this expression into two parts, we change the limit from negative infinity to 0. So this term becomes e to the power at, and signum in this case becomes negative of 1. This remains as it is, e to the power minus j omega t dt. And for the limit 0 to positive infinity, for t greater than 0, that is, the first expression becomes e to the power minus at, and the signum term becomes positive of 1. The remainder remains as it is, e to the power minus j omega t dt. Okay, now simply from some mathematical calculations, we can multiply these two natural logarithms, negative infinity to 0 e to the power, multiplying this term and this term, we get e to the power minus t a minus j omega dt, and this negative will come outside, plus 0 to infinity e to the power minus t to the power minus t a plus j omega dt. Now solving for the integration, we simply get, for the first term it will be equal to e to the power t a minus j omega divided by a minus j omega, the limit negative infinity to 0, plus e to the power minus t a plus j omega divided by negative of a plus j omega, limit obviously being 0 to infinity. Now plugging in the limits in both the expression, we get the first term to be minus 1 over 1 minus j omega, and the consequent following term to 1 over a plus j omega, and upon further calculation we can simplify this term to be negative of twice j omega a plus a squared plus omega squared, just simply adding these two fractions. So we can write the Fourier transform of x of t is x of j omega, which is equal to minus twice of j omega over a squared plus omega squared. So I hope this problem is clear.